Hello everyone, my name is Madhav and I'll be your instructor for today. So, over the next few days, we'll be learning a lot about coding, and today's lesson is just an introduction. We won't be learning particularly any coding concepts today, it's more to help you guys get a feel of what we'll be doing throughout the course. So, the first question that comes to your lips would be why programming? Well, before breakfast, many of us might have interacted with a bunch of computers already, be it a phone, a laptop, or a gaming console. We live in a digital age where programming is used for everything, right? Coding teaches you how to think. It's a fundamental process that helps you think and solve problems. So, this whole journey of coding will help you solve different kinds of problems and help you explore different paths of thinking, different solutions, different methods that might never have occurred to you before. I strongly believe coding is just as fundamental to your thinking as maths and other subjects could be. So let's understand a bit about a concept called binary language. So, like we've mentioned here, computers aren't as smart as us. While we can learn the entire alphabet and number system from A to Z in 0 to 1 to 9, computers only understand two digits, 1 and 0, which represent on and off signals. Each 1 and 0 takes up a unit of memory called a bit. Larger units of memory are defined as in the tables below. So as you can see, one off signal or one on signal takes up one bit. 8 bits make up a byte. And now we can see how 1.024 bytes make up a kilobyte, 1.024 kilobytes make up a megabyte, and so on and so forth until we reach terabyte. So we've talked a lot about concepts so far. Right now, let's look at what a program actually is. So you can very easily represent it in the following form. You can write a program is equal to an algorithm plus data. Let's see what these mean exactly. So an algorithm is a set of instructions to be followed so that we can get the desired output. So let's look at this example, right? This is just an origami sheet to get a cute little puppy. But the point is, to get from this initial stage to this final stage, we follow a set of instructions, right? This puppy is our desired output, this paper is our input, and then we follow a set of instructions so that we can transform this input to this output. Now, like we said before, a program is an algorithm plus data. So now the data is the input we provide the program on which it works to produce some output. So it's shown very neatly by this arrow here. We enter some input data, the program does some process on it, or rather, it uses its algorithm on it and then produces some output data. Let's look at the next concept syntax. So, syntax is a kind of grammar for each programming language. The rules you have to follow while entering commands. So, here are a few examples of programming languages. You have Python, Java, C++, Ruby. Now, different languages have different syntaxes. Let's try to understand what syntaxes are a bit further. When I speak to you all, I have to use grammar to make sure my words and sentences are structured properly so that everyone can understand what I'm saying. Similarly, when we type in a program to a computer and we use a particular, we have to use it. We have to do it using a particular language, and each language understands a different set of grammar. Just like in real life, when I use English, I have to use one form of grammar. When I speak Spanish, I have to use another. When I speak Hindi, I have to use a third. The same way different languages in real life have different grammars, different programming languages have different syntaxes. So the syntax is just the kind of commands and the kind of grammar you have to use while coding in a particular language. Let's talk a bit more about coding itself. So this is how it works. We type into the computer a high level language like in English because typing in binary would be very difficult, very long, and very inefficient. So what programmers do for us, right? We make the use of compilers. So what programmers do for us is that we enter in a high level language. Of course, we first have to remove all the bugs. We'll get into what bugs are at the end of the lesson. But we enter in a high level language, meaning we type in, say, English. We remove all the bugs. There's something called a compiler or interpreter, which converts this high level language that we enter into machine language. Okay. So it takes the high level language program as input and produces the machine language code as output for the machine to use and understand. You can think of it like this: a language that we understand, which the compiler transforms into a language that machines can understand. Now, finally, let's talk about bugs. Bugs are mistakes in the code we write. We have to make sure to debug or remove mistakes in our code before we submit it. It's very important. Bugs can be in the form of logical errors or syntax errors. The point is, we don't want any mistakes in our program. We want our program to give the correct output for the correct input 100% of the time. So whenever you write code, make sure you test for bugs. That's all for today's lesson. We haven't particularly learned any programming concepts as such, but I think you all understood a bit more about what programming is about and a bit about what we'll be learning over the next few days. Goodbye.
To learn these concepts hands-on through fun and exciting games, visit thinkverse.in and start learning now.